Hello and welcome to The Black Ponderer. My name is Neil Trotter. I'm your host. And today we're going to be talking about some philosophy of science. And how we do that here at The Black Ponderer is that we talk about texts to discuss philosophy. And the text we're going to be talking about today is none other than Albert Einstein's Relativity, the Special and General Theory. So, Albert Einstein, famous scientific genius. Then we have theory of relativity, famous scientific theory, game changer, right? When Einstein discovered that theory, humanity changed forever. There's no denying the impact of that theory and its influence on basically every single human being on Earth, from the technology that we use today, anything that's based off of technology, from your GPS, smartphone, geolocation, mass communications, space travel, also just the way we perceive reality and what we know about nature. The theory of relativity is huge. Of course, negatives come from that theory as well. We got weapons of mass destruction, and the atomic bomb. The science behind that is based heavily off of this Einstein's equation, E equals mc squared. You know how you can take anything that's good and turn it into something that's bad. It's always the case with anything, right? But there's no denying the fact that this revelation of Einstein had huge implications and still does to this day. So what is the theory of relativity? In case you're not familiar, well, basically it's the idea that space and time is perceived differently based off of where you are in the universe. And that has to do with the influence of gravity. I'll rephrase that, say it in another way. How you perceive time or how you perceive space may not necessarily be the same. It could be different based off of where you are in the universe, your position in the world. And that's due to the influence of gravity. The famous example that Albert Einstein uses here in this text is this train. And a person on the train that's moving is going to experience time and space differently than somebody that's standing still on the ground watching the train pass by. Now that difference might be very minute, but it's a different perception nonetheless. And from that, you have all these other implications that Einstein goes into with this text. And this text is written for the layman. So what we're going to do in this video is we're not going to talk specifically about what the theory of relativity is exactly. I would encourage you to read this text because it's written for the layman. All you really need is a high school level education on mathematics, really. Multivariable algebra and just arithmetic, basic arithmetic. You learn that with the algebra with multiple variables. I remember I learned it as a junior in high school, maybe a senior, and I went to like a low-funded school. I grew up in the ghetto, so I'm sure the rich kids, they get exposed to that a lot earlier. Basically, this book, this scientific book, is very easy to understand, and with a little patience, most people can pretty much understand what's going on in the text. So I encourage you to read it, or you can watch one of the probably thousands of YouTube videos that explain it, right? Because I'm sure there's a bunch that do that. Or you can watch some of these scientific documentaries that go into detail. I remember I first learned about the theory of relativity watching the Science Channel, back when the Science Channel was actually good. I was like early 2000s. Discovery Channel, Science Channel, TLC, the Learning Channel. They used to be very good. Then all of a sudden they just became reality TV. Kind of like what happened to MTV. Music television. Remember that? But there's plenty of documentaries and tutorials that explain relativity. What we're going to do in this video is, we're going to talk about the science, the philosophy of science, okay? So we're going to talk about the philosophy behind the theory, okay? And what does that mean? We're talking about what does this theory mean, the meaning behind the theory. What does it mean that space and time is perceived differently based off of your position or your speed, how fast you're going, for example. What does that mean? What does it mean that perception isn't the same depending on where you're at? What does that say about reality? What does that say about individuals? What does that say about the nature of existence? Also, I want to talk about how Einstein went about solving this problem. The meaning behind his thinking. How did he think? What was the approach to his thinking to try to figure out a solution to these problems that are coming up, and what drove him to this realization of relativity, this theory of relativity? That's what we're going to talk about today. So, of course, at the Black Ponderer, we're going to start off with some quotes. We're going to read some quotes, and then we're going to add some supplemental commentary. Right here I have the Penguin Classics edition. I love Penguin Classics. It's no secret. I'm still waiting for that sponsorship from Penguin. I'm still waiting for the sponsorship. No, it's not coming. Oh well. They're like, why should we pay you? You give us free advertising. There's no point. Oh well, I still love it. But okay, well we're gonna read. This is page 8. In case you're following along, in case you have this book. By the way, you can just download this for free off the internet. But we're going to read page 8, first paragraph. The concept true does not tally with the assertions of pure geometry, because by the word true, we are eventually in habit of designating always the correspondence with a real object. Geometry, however, is not concerned with the relation of the ideas involved in it to objects of experience, but only with the logical connection of these ideas among themselves. So he gets philosophical right here. He's talking about truth, and what does truth mean? And he's talking about geometry and what is real, right? So he's getting deep right here, What he's saying is, look, sometimes we fool ourselves, or we limit the way we think because we trap ourselves and we put ourselves in a frame, like geometry, right? Is a frame of thinking. And then we make up all these rules, and then we kind of set it up where things are proven to be right based off of this frame. But the frame might not completely encapsulate what's really going on, the truth behind the situation. Geometry by itself might not specifically explain reality to its fullest extent. You might say, oh, because I've used the rules of geometry, and it all works out, so it must be true. But Einstein said, look, maybe our rules of geometry are limited, and what you come out with as true is just true based off of your limited frame. But what about everything that's outside that frame? We have to start thinking outside the box. This is what Einstein is implying. The conviction of the truth he puts in quotation marks, of geometric propositions in this sense is founded exclusively on rather incomplete experience. By the way, this page 9, last paragraph. We shall see that this truth is limited, and we shall consider the extent of its limitations. There you go. Up until that point, geometry had a very limited frame, and he goes on. Einstein talks about the coordinate system, the x and the y, and then the z if you use 3 dimensions, and how you map everything, and how everything is like a perfect rectangle or a box, right? When you map things out and everything's a straight line, and how you map things out on a 3-dimensional coordinate system. And he goes on to say that, look, that's a very limited way of perceiving reality, and we need to start thinking about a different way to perceive how we map out space. So we're going to move on to chapter 8, and the title is On the Idea of Time in Physics. So in this chapter, he uses this example. He says, okay, we're going to imagine this situation where lightning strikes 2 positions. Like you're witnessing two bolts of lightning and they strike in two different positions. You see it, and it looks like they're striking at the same time. That's what it looks like. And then he says, okay, let's set up, to make sure that that's the case, we're gonna set up a mirror, and we're gonna put the mirror in a position where you can observe both of them at the same time. These lightning strikes, and they strike exactly at the same time. And you're at a distance, and you use this mirror, and you see the lightning strike, both bolts of lightning striking at the same time. You're like, oh, okay, yeah, I see it. I see that the lightning is striking. I see that these two bolts of lightning are striking at the same time. And I'm using this mirror to do that, and that's what it looks like. But when Einstein is saying like, okay, but just because you think you see it that way, it's not even an issue of thinking. You actually observe that. Your eye, using the mirror, you observe that. But still, that is your limited perception. That still might not actually be the case. Those two bolts of lightning might not have struck exactly at the same time, even though you observed those two bolts of lightning striking at the same time. So he creates a hypothetical you, like Einstein's telling you that in this book. He's saying that might not be the case that they struck at the same time. And so you answer in his hypothetical scenario here. This is you, this is me, this is the answer. I maintain my previous definition nonetheless. There is only one demand to be made of the definition, namely, that in every real case it must supply us with an empirical decision as to whether or not the conception that has to be defined is fulfilled. That my definition satisfies this demand is indisputable. Neither a supposition nor a hypothesis, but a stipulation which I can make of my own free will in order to arrive at a definition. So we're trying to defend ourselves, right? Well, I set up the mirror and I saw that those lightning bolts are at the same time, and I set my experiment up perfectly. So, we observed it. So obviously that's how it is, right? But Einstein is questioning you. He's saying like, yeah, but it's your stipulation. It's the way you stipulated the experiment. It's not the supposition. You didn't provide a supposition, or you didn't even provide a hypothesis. Right? You just put up some stipulation and say, oh, there it is. That's how it is. That's my definition based off of my stipulation. And Einstein is saying, okay, we gotta stop doing that. We gotta stop putting up these stipulations and then just setting the experiment up or the situation up based off this stipulation, which we've kind of conformed to make true already beforehand. We gotta think about the supposition. We gotta think about the hypothesis. That's how you think scientifically. I'm just reading my little notes right here that I wrote in the margins. We make conclusions by faulty frames, okay? Frames of science, for instance. We assume that our perception is true, right? We presume that the way we see is perfect. Like if we see two things happening at the same time, then they must have happened at the same time. That's a stipulation, right? But that's a faulty frame. Our eyesight is not perfect. We assume this to be true. So Einstein's saying question everything. Think outside the box. Okay, that's very important in science. We got to question everything. We have to think outside the box. You have to consider, maybe just because I'm seeing those two bolts of lightning being struck at the same time, does that actually mean that these two bolts of lightning are being struck at the same time? Or is my eyesight, my perception of seeing, stipulated in a certain way? That's just how I see things, and that it might be the case that that's not true. Let's assume that the way I perceive things are not true. Maybe how I see those two bolts of lightning hit at the same time, maybe that's a false perception. If that's the case, then where do we go from here? And Einstein thought that way. He said maybe my perception, or the way I perceive time and space, is different based off of where I am or my position, or the way gravity influences my space, my time. somebody at a different position than me, or somebody that's moving at a certain speed or velocity, they might perceive those two bolts of lightning very differently than me just standing here observing those two bolts of lightning. Which one is correct? And indeed, he found out, it is the case that somebody, for example, on a train moving is going to perceive those bolts of lightning striking at different times as somebody that's just standing there. So which one is correct? Which one is right? Is the guy that's standing there wrong, or is the guy that's moving on the train, is he wrong? Eventually, Einstein comes up with the conclusion that they're both right. The person moving on that train that sees one bolt of lightning strike slightly faster than the other bolt of lightning, that person's perception is correct. At the same time, the person that's standing outside the train on the ground, and that person that sees the bolts of lightning hit at the same time, that person's perception is correct too. The thing is that gravity alters space and time in a certain way that our perceptions are varied, that our perceptions are relative. So I'm moving on to chapter 11, which is called the Lorentz transformation, which he describes as mathematical transformation to try to compute these variances in perception of time and space. So he puts these two axioms into question. Okay. 1. The time interval, time, between two events is independent of the condition of motion of the body of reference. 2. The space interval, distance, between 2 points of a rigid body is independent of the condition of motion of the body of reference. So Einstein goes on to say, if we drop these hypotheses, then the dilemma disappears because the theorem becomes invalid. So the assumption before up to that time was that time and space, distance, are independent of velocity, speed. They do their own thing. They're not influenced by the motion of bodies, how we move. And Einstein thought, no, actually, they are dependent. Time and space are dependent on how fast we move, the velocity of particular bodies. And because of that, different perceptions of time and space are valid. Some person might perceive time and space differently than somebody else because of the way how fast they move or how slow they move. But both are valid. Both are true. So I read my notes. When questioning given assumptions, new considerations of knowledge become available. Question everything. Don't just assume your perceptions are correct or you're the only perception that's correct. Okay. Take into consideration the perceptions of others and don't just assume that what you see or what you hear is automatically correct from the get-go. That's very important. You really do have to think outside the box when it comes to not only science, but just life in general. What I like to do is read this quote from chapter 15, General Results of the Theory. Okay, we're just reading quotes. This is page 47. The success of the Faraday-Maxwell interpretation of electromagnetic action at a distance resulted in physicists becoming convinced that there are no such things as instantaneous actions at a distance. So what is this Faraday-Maxwell interpretation? It's basically, this theory of relativity. Einstein just didn't come up with it just on his own. I mean, he actually built this theory of relativity off of other theories and experiments and observations from other scientists and researchers and experimenters as well. So he's given credit where credit is due. And based off of what Einstein thought and what his contemporaries at the time, they came up with this concept of, look, there are no such thing as instantaneous actions at a distance. So again, we're going back to that lightning, those two bolts of lightning striking at the same time. That actually doesn't happen at a distance. Okay, even though you perceive that to be the case. even though that is of the type of Newton's law of gravitation, because Newton's laws are based off of those old school observations, those old school perceptions. Now, that doesn't mean that you're not actually perceiving it that way. That's not what it means. It means that you are perceiving it that way. You do see those lightning bolts hitting at the same time, but that's not what's actually happening. Okay, your perception is limited, and we have to delve deeper and think more deeply to understand that. According to the theory of relativity, action at a distance with the velocity of light always takes the place of an instantaneous action at a distance, or of action at a distance with an infinite velocity of transmission. This is connected with the fact that the velocity c is the famous letter that scientists use to represent the speed of light. Velocity of light, c, plays a fundamental role in this theory. So we're talking truth by examination versus reality based on perception. That's what I wrote on my notes. So what am I getting at here? Why did I read those quotes? We're not talking about the actual theory of relativity here. What we're talking about is the philosophy behind the theory. We're talking about how you should always question everything, okay? Don't initially trust your perceptions, because your perceptions are limited, okay? And that was what Einstein came to the realization. He said, okay, we're using these rules of thought, or these scientific methods that are based off of our limited observations. So what we really have to do is we have to delve deeper. We have to think about in what way are our perceptions limited. And when we approach paradoxes and contradictions, is it the case that they actually are paradoxes or contradictions? Is that actually the case? Or is it the situation that what we're using to measure or identify what's actually going on is limited, is restricted? The frame is too small. Okay, maybe if we expand the frame or rework the calculations or think about things differently, then we can, then these contradictions will not be contradictions anymore. They'll be like, oh, okay, really it's just like my perception is different based off of this other perception because of where I'm at in space, how gravity influences me, my velocity, my speed relative to the other objects in different motions. And it's important that we do that, not just in science, but in all types of other ways of thinking, in critical thinking, whether that be mathematics, societal situations, economics, all types of things about reality and nature. When we're confronted with things that challenge the way we perceive reality or the way that we understand truth, don't be so dismissive. Okay, think, question what's actually going on. Consider that, am I actually starting from a hypothesis or a proposition, or am I just basing everything off of stipulations that I've just built that, you know, work out to these perfect answers that may or may not be true some of the time, or I'm trying to pigeonhole my answers or what I think reality is into some sort of a predefined frame, all right, that may be false. Think outside the box. This is what science is all about, baby, or the philosophy behind science anyway. And again, I encourage you to check out this book, or this text at least, Einstein's Theory of Relativity. He's broken it down. This is specifically written for the layman. Albert Einstein tried to break it down so that any person with patience could sit down and read it. You know, you don't have to be a genius, a professional physicist or cosmologist to understand what's going on. Well, you've been watching The Black Ponder. Tune in next time for more philosophical thought.